Hello, Mr. Betts here. Let's take a look at another example where we're evaluating a definite integral. And this time it's an absolute value function. So keep in mind that we can redefine absolute value functions as piecewise functions. And then once we have it written as a piecewise function, we can split the integral up into two separate integrals. So what I'm going to do first is I'm going to redefine our integrand. So the absolute value of x squared minus 4. And that's going to be x squared minus 4 as long as x squared minus 4 is at least 0. And it's going to be the opposite of that so 4 minus x squared when x squared minus 4 is less than 0. So the absolute value is changing the inside of the absolute value to the opposite when it's negative. So rewriting that, so this function is going to be x squared minus 4, and so x squared minus 4 is positive for values of x greater than or equal to 2 and less than or equal to negative 2. I should say positive or 0. So x is less than or equal to negative 2 and x is greater than or equal to 2. And then it's going to be 4 minus x squared for values between negative 2 and positive 2. So what I'm going to do then is I'm going to rewrite this integral, this definite integral, as two separate definite integrals, one going from 0 to 2 using this, and the other one going from 2 to 4 using this. So this is equal to the integral from 0 to 2. So from 0 to 2, this function is going to be 4 minus x squared plus the integral from 2 to 4, and now the function is going to be x squared minus 4. And so we've seen this before. Now we just evaluate each one independently. So the antiderivative of 4 minus x squared is going to be 4x minus x cubed over 3. And we're evaluating that from 0 to 2. And then this is going to be, the antiderivative here is x cubed over 3 minus 4x. And that is being evaluated from 2 to 4. So now plugging in our limits, we're going to have 4 times 2 minus 2 cubed over 3 minus, plugging 0 in there is just going to be 0. You'll find that using 0 as a limit with integrals, especially polynomials, tends to be pretty easy because we end up subtracting 0. Then we have plus 4 cubed over 3 minus 4 times 4 minus 2 cubed over 3 minus 4 times 2. So I do want to point out that this expression here and this expression here are the same, and distributing the negative, they're exactly the same. So they end up doubling each other up. That's the expression that we got at 2. If we had done this incorrectly and just tried to do the antiderivative of x squared minus 4, we would have lost that term entirely when we end up using that term twice. So it is very important that we rewrite an absolute value using a piecewise function first and then evaluate it on two separate intervals. Also, like other ones that I've done, I'm not going to spend time simplifying the expression. That is a number. You simplify it, you get something that's probably a third, something involving thirds, but that's not the focus here. Once we get a numeric answer, then we can stop.